All right, recording's rolling. Let's take a look at this one. All right, so here's your guys' first progress check. Guys, have this done by the end of the weekend so that when you guys come in on Monday morning, then we can go over the solutions. It might take us a couple of class periods to go over all these. Most of these questions are linear motion questions, but there's a few at the end that are projectiles. Now, this one right here is a pretty tough challenge question. So I want to help you guys how to think about this one and maybe give you guys a couple of hints. Okay. And so we got a golfer strikes a golf ball that is initially on the ground. Okay, just like that picture. The ball leaves the ground with initial speed v naught, right, which they have right there. So it's like the strike speed at an angle theta relative to the horizontal. Ooh, all right, that seems pretty in line with some projectile stuff you guys have seen last few days. Right. And travels toward a vertical wall. Oh, there's the vertical wall right there. The ball collides with the wall at the instant it reaches what would have been its highest point if the wall wasn't there. And, okay, you can see that from the picture too. Because, guys, what shape is this dashed line right here? Yeah, it is a parabola. And, guys, what point on the parabola is that at the very top? Vertex. That would be the vertex right there. If the wall wasn't there, then the ball would be moving horizontally at that point and then start to move down. Right. The ball rebounds from the wall with the same speed it had struck the wall. Right. Okay, so if it's coming in at like 5 meters per second to the right, it's kind of boing, and now it's going to rebound 5 meters per second to the left. Now that's true. If it came in horizontally at some speed and then it rebounded with the same speed opposite direction, do you think it's going to exactly follow this dash line also back down to the golfer? Right? It would have to do that, wouldn't it? A few weeks from now, we'll talk about that type of collision. It's called perfectly elastic. Right? Rebounds from the same speed as struck the ball. And then lands at the same point. Of course it does. We just talked about that. From which it had been struck. Which of the following is a correct expression for the horizontal distance between the ball's initial position in the wall? Right. So if you threw in a variable x, maybe, right? You guys see this distance x from here, right? So x equals what? Right. Now, if you glance down at the multiple choice answers, then you can kind of get an idea of the framing of maybe how to go about this. Right? I know it's really tiny font. Wait, can I zoom in on this all? Okay, a little bit. Right. I see. Thank you. Okay, so what variables do you see and what do you not see? Right, and you guys know that every single one of these could be x equals something, right? So x equals any one of those expressions, and of course, only one of them is correct. So, okay, so V naught was the strike speed. Theta is the angle relative to the horizontal. Oh, and hey, G, gravitational field, that probably matters too, right? That matters too. Okay, and all these, again, there's only one of these that's correct. It's multiple choice, right? But they only deal with those 3 variables. That's interesting, right? There's lots of ways that you could hit this that would satisfy those initial conditions for the setup. Like, guys, for example, what if you struck this at a really high speed and it went like a really flat parabola? Could it do that? Could it like bounce off the, say, like the first floor window, something like that, right? Or what if you hit a little bit slower, but also a little bit steeper at the same time? Could also peek at the vertex up here, maybe at the second floor window. Or what about a little slower, a little steeper? Okay, so already I'm playing around with the variables between speed and strike angle. Say, okay, well, if I shoot it slower and slower, I can shoot at a steeper angle, right? I kind of see that, right? You guys be able to play around with that when you're on, right? How about gravitational field? Let's play around with that. What if you did this on the moon, where there's hardly any gravity at all, right? Do you think, do you think this parabola would be closer to a straight line looking like, you think, right? So if you hit it at that speed at that angle on the moon, it probably would not reach the vertex right at this point. It'd probably be like way over to the right, maybe something like that. Right? Okay, so you can play around with the gravitational field. And what if the gravitational field was really strong and versus really weak? Right? Well, if it was really strong, maybe you'd have to hit it really hard. If it was relatively weak, maybe I don't hit it as hard. Right? Or again, you could play around with the angle, something like that. Right? So we got all these variables playing with each other. Right? Right. But there is some solution that regardless of how fast you hit it and regardless of the angle you hit it, and regardless of the gravitational field, there's some combination of those variables that's going to satisfy this, right? So it's pretty tough. Now you can solve this. I was able to solve this with a two equation system of equations. Okay, two equation system of equations. Right. Right. So some hints about that. One of your equations involves the fact that this is the vertex of a parabola up here. Right now, you're just using the physics equations, right? It's some version of those three kinematic formulas we've been using for the last few weeks. Right? If you know that right at the very top here, right, it's going to, or what would that physically mean? Like in physics terms, the fact that this is the vertex of a parabola. So maybe to do with some component of velocity, maybe, or something like that. Right? What was the other? Oh, the other hint I want to give you. Hey, what? Right. You guys know we've been juggling 5 variables for the last few weeks, right? We got time, acceleration, displacement, initial velocity, final velocity. There's something to do with that, right? Which of those 5 variables have you not seen mentioned at all? I don't see written anywhere in the answers. I don't see, well, all these is like x equals something, right? They're all x equals something. Okay, so displacement's in there somehow. Okay, that's what I'm looking for, time, right? You guys don't see anything about t time. Now, of course, it takes some time for all this to play out, right? Right, guys, the fact that you don't see time in any of the answers might be a really strong hint that that variable was substituted out. When you guys have solved systems of equations before, right? And a lot of times, one way to solve systems of equations is you substitute out a variable. I wonder if time was substituted out in the equations. Okay, right, you guys can I see that? All right, so that's all the hints I want to give you on that. Again, pretty tough puzzle right there, but see if you guys can do well on that one.